We've been looking at this idea of a sampling distribution of the sample proportion. And so there's lots of things that you can do with a sampling distribution, but our goal is use it to make a decision. That's what we want to do. And so typically you're told some type of information, and our goal is to see if we can find support for some claim or conjecture that's been made. And so we've had ways that we've talked about doing that, and you see some pretty consistent questions that come up over and over and over and over again. So we're still in that world. So according to census estimates in 2010, so old, right? 2010, long time ago, census only happens every 10 years. The census is when we're supposed to try to get information about everyone that lives in the country. And so you kind of do the best that you can. And so according to those estimates, 72% of all US citizens were registered to vote. Now, if we just kind of stop there, there's some important pieces in that question that we can consider. So first off, if we thought about this phrase, all US citizens, what does that make us think of? Population, right? All is sort of in the buzzword for population. And so we can think of all US citizens as our population, which means that that 72% is describing a population. Fair? Now, we know that 72% of all US citizens were registered to vote. And what happens in years with presidential elections, so it's coming next year, they usually make a push to get more people to register to vote. So maybe you've got folks that just turned 18, and so they're not registered to vote yet. You want for that to happen. So we want to know if that push, let's get more people to register to vote, has had an impact on voter registration. And so to make that decision, you sort of have one of two ways to go about it. Option one is you ask every US citizen whether they're registered to vote or not. Well, I could do that and I would be here until the same time 10 years later, right? When I'm still trying to find all US citizens. And so what we decide to do instead is we're gonna base our decision, we're gonna base our conclusion on a sample. So we're gonna take a random sample of 300 American adults and determine what proportion of those adults is registered to vote. Now, when we think about this, we are in module 2, we talked about a lot of definitions. So population that we just highlighted was one of those definitions. Sample was one of those definitions. The variable that you're looking at, what kind of variable it is. And so when you think about the test that's coming up, I am never going to ask you to spit back verbatim, define population, right? But I will ask you, here's a scenario, what is the population? So that's how we've practiced all of those. Does that make sense? So there's no need to have your flashcards and memorize exactly the words that I said when we define population, but you do need to be able to pick it out when you've got a scenario. So the same thing is true for variable. You're going to see that question a lot, not just now, but in the future. And so when we think about the variable, the way that I like to think about a variable is, what question was asked? And you can think about it as what question was asked of the sample. And so in this case, we know we had a sample of US adults. If we're talking about people, I like to just imagine that I was in the sample. So if I was one of those individuals that they sampled, what question are they going to ask me? Yeah, are you registered to vote, right? Now, when you read through the question, there's lots of things that might sound good, right? So in some cases, folks like to say, well, they're probably going to ask what percentage are registered to vote. I don't know how to answer that question, right? So when I think about my variable, it has to be something that's personalized to those observational units. And so we would say, are you registered to vote? And when we answer that question, we're going to answer it with either a yes or a no, right? I either am or I'm not. And some people could say, I don't know, but just go with yes or no. And because I'm answering that as yes or no, my type of variable is categorical or quantitative. Which one? Yeah, it's categorical. So that question is seeking to split us into groups, those who are registered to vote and those who are not. Now, the whole reason that you think about, let's collect some data, is I want to be able to make some decisions, right? And so when I try to make a decision, typically I have something in the back of my mind that I think might be true. And so that's certainly the case here. So I've got this idea that I think my push to register folks to vote is going to have an impact on that 72%, right? And so if I've had impact, if it's done what I think it should do, our conjecture would say that more than 72% of US adults are registered to vote. That's what I hope has happened. And so what we're gonna see in everything that we do, I can have hope in that conjecture all I want to. But if the data doesn't suggest that that's happened, it doesn't matter how much hope I have in that conjecture. Right? So everything that we decide, the decisions and choices that we make are all gonna be data-backed decisions. That's how we're gonna do it. It's not just our gut instinct says it. We're going to actually have information that helps come to an accurate conclusion. Now, in order to make that decision, I sort of have to know what to expect. So what are some reasonable outcomes that we might get if nothing has changed? So if I had no impact, nothing's changed, what are outcomes that are possible? And so that's what happens when we're in this situation, when we're asked to describe our sampling distribution. And so describe the sampling distribution is something that we've seen over and over and over again in this section. It's in bold for a reason. It's sort of like when you see the word probability and there's a link in your head that says z-score, go to the normal table. This also needs to have a link in your head that says, okay, I know what I'm doing. When we describe the sampling distribution, the three characteristics that we're looking for are our shape, our mean, and our standard deviation. So always those three pieces. And we've talked about those. So when we think about those three characteristics, let's see if I can find the right page. Doubtful. There's where we talked about them in the notes. So as long as we've satisfied these two checks, for our shape, we can say the distribution is normally distributed. So I know that lets me draw a bell curve, but it doesn't give me enough information to figure things out. So that's where we also need our mean and our standard deviation. And so in thinking about that description, I don't care which piece you look at, they all involve N and P, right? Every time we do it, we have to know what our sample size is and what our population proportion is. And so if we go back to our example, we can figure out those pieces. So I'm going to come up here to the top and think about this information that we know. So what are we given? Well, according to our description, we needed a value for our sample size. So sample size was N. We need a value for our population proportion, P. Well, N's probably the easy one because our sentence says that we took a random sample of 300 American adults. So we've got a sample size that's 300. And then we just decided that that 72% was describing our population. And so we can't say that P is 72, right? Because the P, when we think about that, it's a proportion. And proportions are between 0 and 1. And so it's my responsibility to take what we were given, that was a percentage, and move our decimal place 2 places to the left so that now it's a proportion. So P is 0.72. All right, so let's talk about our shape. I can't tell you anything about the shape until I've done our checks. So when we think about the checks that we look at, we wanted to calculate N times P and N times 1 minus P. And we didn't get into the why, right? We didn't get into the why. That's theory that's really beyond what we do. But knowing that these are large enough is what will allow us to say that our distribution is normally distributed. So we had a sample of 300. Our population proportion P was 0.72. And so we get a calculation that's 216. I will do the same thing for N times 1 minus P. And there we get 84. And so we're comparing those numbers to 10. They're both greater than 10. And so I've satisfied my check. Now, here's something that sometimes gets a little bit messed up. We have this idea that there's numbers and there's calculations. And so if I've shown you the math, I'm good. I don't have anything else to say. That's not true. This is helpful, but it didn't tell me the shape, right? Like you gotta come back in and say that because those values met our condition, we can come to the conclusion that our sampling distribution is normally distributed. So those two numbers that we've got don't tell me what picture to draw. That does, right? Once I see that it's normally distributed, I know that I could draw a bell curve. Now, knowing it's a bell curve is helpful, but not the whole story. So we also need to know the mean of our distribution. And our formula says that distribution is going to pile up over our population proportion. So it's going to pile up on that value 0.72. Now, in saying that, we're making an assumption, right? We're saying nothing changed. We're not going with our conjecture that it's more than 72%. We're sticking with status quo, what we were told, until our data leads us to a different conclusion. Now, our standard deviation, that's going to help us figure out the scale along the axis of our distribution. So what are the numbers that we expect? Well, we've got all the values that we need to plug into our formula. So we know that P was 0.72. We know that N was 300. And so we can sub everything in to that formula. And we've done this calculation a lot. I've lost track of how many times we've done this calculation. You're going to do it more on homework. So you've got your standard deviation. We've practiced it. We've practiced it with our calculator. So we know that we're getting the right number out. If you have only practiced it with your phone, phones aren't allowed on Monday. So you can't use your phone calculator on Monday. So you've got to have a calculator with you. So your standard deviation that you get is 0.0259. So here is what that's going to allow us to say. So we, from our shape, knew we could draw a normal distribution. What we're describing with that normal distribution is sample proportions p hat. So when I take and my sample of 300 US adults, I ask them if they're registered to vote or not. Those sample proportions is what this is describing. That second characteristic says that we're centered at a value that's 0.72. And what the standard deviation allows us to do is we could think about being 1, 2, or 3 standard deviations from the mean. Now, I could draw on the left too, right? That's fair. But if my conjecture says more than, feels like the right side of the curve is where I would want to fall to find data that supports that claim. And so I'm really just worried about the right-hand side. So I could imagine this is 0.7459, right? 0.72 plus 1 standard deviation of 0.0259. I could go 2 standard deviations. So that would be 0.7718. And I could go a 3rd standard deviation That's 0.7977. Is that okay? It's just what that description is giving us. So it goes back to where we started. When we started with the empirical rule, it all still applies here. And so what we need to know next is, well, what happened when you took 300 people and you asked them your question? What'd you get? What were your outcomes? Did you fall way out here? Are you here? Are you real close to 0.72? What kind of data did you get when you talked to 300 US adults? Well, I know. So I took my sample of 300 potential voters, right? They were just US adults. I don't know if they're registered to vote or not. 228 were. So I need now to find a probability. And so our probability, right, that's a buzzword. It's where we think about our z-score and going to our normal table. The type of probability I'm looking for was a greater than. So I wanted more than 228 folks registered to vote, because my conjecture was a more than. So that's where everything's kind of lining up for us, right? Our claim said more than 72% are registered to vote. And so I'm going to find a greater than, a more than probability. Now, here's the challenge that I think we run into. So we've got our normal curve on the board, right? We did our description, everything looks good, we're in a good spot. And if you just read that question, and your question talks about more than 228 people, doesn't fit on that picture anywhere, right? If this went from 0.74 to 0.77 to 0.79, if you tried to think about where 228 fell, I don't know, you're way there, right? Like it doesn't even make sense to talk about 228. Well, that's because it's not yet scaled into a proportion. So everything that we're talking about is scaled as a proportion, and 228 is a count. It's just a how many. And so when we've talked about our sample proportion, p hat, we've said, well, I can think about that as part over whole. So the part of my sample that was registered to vote were the 228 individuals out of the 300 that we talked to. And that makes sense, right? So if I think about this normal curve that we've got, we said in our description that it's centered at 0.72. And so 0.76 is around there-ish. Does that kind of make sense? Thinking about the scale that we drew over here. I feel like 0.76 is going to be somewhere here. And so the area that we're interested in is that more than. Well, so now I need my z-score, right? I've got to standardize to find a probability. And so the formula that we wrote down in this packet of notes was a mess. right? That was the formula. And you're like, I don't like anything about that. Fair. Well, another way to think about that formula is that it's just this. And so everything that's down here in the square root, that was our formula for standard deviation. This was our formula for the mean. And we've observed a sample proportion p hat. And so on the formula sheet, you're going to see that version of the z-score. I don't care if you ever use it, right? All you got to think about with that z-score is what we've written in words. And so we have an observed proportion that's 0.76. Our mean was 0.72. And our standard deviation was 0.0259. And so be careful with the order of operations. That should give you a z-score that's 1.54. Now, rounding, let's talk for a second. I will always round z-scores to 2 decimal places. Table only goes to 2 decimal places. Everything else, I keep at 4. Right? So we didn't round our standard deviation to 0.03. That causes massive round off discrepancy when you do your calculation. So if you'll keep 4 decimal places everywhere else, then you're going to be good. So once we know we've got our z-score, so we've got this z-score that's 1.54, that's when we need to go to our normal table. So we practiced, we know how to use this. When we think about this normal table, we had a z that was 1.5. So there's my 1.5 row. 4, right? And so where that intersects was that area of 0.9382. But our table only tells us areas to the left. And so if I come back to my picture, what we have found from our table is this area. And that's not what we shaded. Again, we practiced this, right? When it's a greater than, what are you always doing to find your probability? Subtracting from 1. And so to answer our question and come up with our probability, we'll take 1 minus 0.9382. And so you come out with a probability that's 0.0618. So here's the thing. If nothing has changed, if it's still true that 72% are registered to vote, my sample or something more unusual is not very likely. Right? That's a really small probability. If someone told me that there's a 6% chance of rain, not packing an umbrella. Not saying it couldn't happen, but I'm not going to worry about it, right? And so what this says is, okay, you got two ways to think about this. Either your sample is just really unusual. That's fair, it can happen. Or that number in the middle was never right. I'm going with that one. I don't like to just say that something's unusual. That feels odd and strange. And so I'm going to bank on that underlying assumption that we made being incorrect. And so when we get to this point where we're going to make a decision, we had rules of thumb that we were going to follow. And we're going to formalize this a little bit more in our next module of notes. But for right now, I needed a cutoff, right? The whole point of calculating a z-score was that we standardize. We're all on the same page. We all got the same answer. We're not just making our best guess at what we think is right. And so the cutoff that we're going to use right now is our 10%. So if our probability is smaller than 0.1, so it happens less than 10% of the time, I'm going to say that my sample's unusual. That claim I made, feel pretty good about it. So if we think about doing that here, we're comparing our probability. So what we just calculated to a cutoff of 0.1, so 10%. Now, if you don't like comparing decimals, imagine that they were dollars and cents. I'm comparing 6 cents to 10 cents. 6 cents is smaller. So since our probability is less than our cutoff, that tells us that we've observed a small probability. And what our sentence had said is if you get a small probability, what would make my sample look more likely? If I could scoop that whole curve over, right? If I could just slide that curve over, it would make it look as though I've captured more area, but to slide the curve over, more than 72% have to be registered to vote. And so we can say the following. We have convincing evidence. So our data led us to convincing evidence, not our gut. That more than 72% of all US adults are registered to vote. And so my probability hit that cutoff. It hit my tipping point that would push me to this conclusion. If your sample proportion had been not that large. So let's imagine that your sample proportion had fallen here, right? Let's just say it was there. You can already tell, right? You would have shaded a whole lot more of that curve. You would have had a much larger probability. And so if this had been my sample proportion, it is too close to 0.72 for me to call. Does that make sense? And so the only thing that would have changed in my sentence is we would have said, well, now we have a large probability, and so there's not convincing evidence. But my sentence is always about my conjecture. I either have convinced myself that I'm okay to say that that's the case, or I've not convinced myself. Does that make sense? I'm never gonna go back and say, well, you know what, the census was probably right. I don't believe that. I think things have fluctuated some. My data just didn't lead me to be able to make that conclusion. Is that okay? All right, any questions on that? So beginning to end. Sort of starting to make sense. You're gonna see the standard questions. So you're gonna be asked what your conjecture is. You're going to be asked to describe the distribution. You're going to be asked to find a probability. You're going to be asked to use that probability to make a decision. It's just the way things are going to go. All right. Now, let's talk a little bit about the test. Okay, so test is on Monday. Test covers modules 1, 2, and 3. So everything that we've done so far. In module 1, we talked about normal distributions, how they link back to the empirical rule, use those to find probabilities. In module 2, we started in on some definitions, always related to a scenario. And then we looked at describing distributions with bar graphs. And then module 3 has been this idea of a sampling distribution. Now, we've done work in all of those areas, right? So if we look in module 1, you've got a learning check that's there. There's a video solution for it. The homework is in review mode, so you could use those homework problems as practice if you wanted to. We did the first attempt at learning check 2. You've got the second attempt open through the weekend. Had to think about that, where that fell. So if you want to work the second attempt, that's there. Homework 2 is due this evening. So you got to have homework 2 finished tonight. And then today, we're going to work on learning check 3 to give you some practice. You've also got homework 3 that's up. Now, if you look under this exam 1 module, so exam 1, I tried to give you more details about it. So we're during class on Monday. So we've got the test on Monday. It's going to cover modules 1 to 3. On the next link, I'll show you in a second, there's an exam review. We're going to talk about that. The formula sheet is linked. So here's the formula sheet that you'll have a copy of if it decides to open. Canvas is slow. I'll keep going. So here's my recommendation. You've got the formula sheet. Work those review questions with just the formula sheet without going back to your notes. And if you get stuck on something and have to go back to your notes, that's something you need to work more on. Does that make sense? So see what you can do with just the formula sheet if it decides to open. Still spinning. Just let that spin for a minute. On Sunday night from 6 to 8, I'm going to be in the Math and Stat Lab. Math and Stat Lab is virtual on Sunday nights. And so there's a link in Canvas here. If you click that link, it talks to you about the Math and Stat Lab, and you can go here to sign in to the virtual space. It's this little room that we created on gather.town. It's lovely. Anyway, you'll make a little avatar. I have a little avatar. It's sort of like Zoom, but not. It's a little easier to interact with people. So I'll be there for those 2 hours. And then I gave you some sense of keywords, right? So some of those things that we've talked about in bold that I hope spark, oh, right, I know what to do with that. This is important. You got to have a calculator. I will bring some. I'm going to tell you they're not good calculators. They're just ones that I have found. And so bring your calculator, please. Don't rely on my crummy calculators. And you also need a copy of your normal table. So I won't have extra copies of the normal table. I need you to bring yours. Now, the next thing that's posted is this exam review. And so it is just an exam review that's in iMath. It's nothing that you have to do. It's not part of your course grade. But what I did is I took one of my exams from, I don't know, 2 or 3 years ago and just made them iMath questions. So you got what was a Stat 205 exam from me in IMath. Now, you're not taking your test in IMath, right? So you can imagine that when you hit one of these questions, right? Matching, fair enough, that would work. This was just a fill in the blank where you were describing a bar graph. We've done those, right? Like your learning check question. If you think about, this is the one I want. This question, where you're talking about something that was normally distributed. Again, very much like a learning check question. I just transitioned it so IMath could do it. Does that make sense? And so if you think about those review questions and you write them out on paper, just like you wrote out learning check questions, you have a really good sense of what an exam looks like. All right, so the goal is to get you some practice. And so you got all the things there. I am not telling you that this is the test, right? I am telling you this is a test that I wrote a couple of years ago that I gave in a comparable class. You have some sense of what type of questions to expect from me. All right. So any questions about exam one? You know where to find everything? So you've got a whole module on Canvas that's talking about what the exam looks like. That's exam one. And then you can access that review on IMath if you so choose to help you practice for some things. If you do an IMath question, you're like, man, I don't know about that one. Go back to homework questions to get some additional practice. Or if you didn't do the second attempt of a learning check, go to the second attempt of a learning check. You can get some more practice that way too. So you can use any of those resources at your disposal. Now, what we're going to finish out today looking at is we're going to look at a learning check for the sampling distribution. So this is first attempt. So this one's got to be turned in tonight. I will grade it tomorrow. So I'll do that first thing tomorrow morning. So you'll have grades reported by like afternoon. And so you'll have feedback on that learning check. If there's anything that you need to think about changing the way you wrote it up so you're ready for the test. All right. So there you go. Work on those questions. Given that everybody has COVID again, I went back to that. Where it's landing. Well, it's natural. And then yeah. Yep, but then when you move that back twice, you got to 0. Good job. Yeah. Yeah, anytime it's spirit, it's spirit. I like to just put myself there. Does that make sense? And then you. While you're thinking about it, point, one word. Well, it's yours there. It's a second, just a second. So like when you do a. I don't know how to check this off. Had to reject that I would. We need to, but I will try. You can say, okay, everybody, ever. If it's gonna hurt me, they always basic. And so like anytime you watch TV, if they do the drug commercial, X person. It's an S. So that's all this person. And so they want more possible. Yeah. So. Oh, yeah. Yeah. No. So what do they think? Yeah, that's very much your structure. And so it's a job that was more than 6%. So that's what they describe. Well, one is completely go back to your notes, but you describe the characteristics. Okay, yeah. That's it. One of those two. No. Yeah, I was just like, yeah, no. Because it's so. So it's usually buried in there. Yeah. Yeah, one is. Yeah. Okay, well, let me show you. I should figure out how to put in a calculator again, like the thing and yes. And 0.06. Trying to see. So then what do you about how you decide, right? And it's, I know how to decide it's small or large, right? But if it's more than or more than likely or less likely. Yeah. Okay. So when you think about yeah. So they all what that drives. Okay. Yeah. Far away. Yeah. The data is okay. Is 2 points. Okay. And so that makes more sense. Yep. Thank you. Correct. There wasn't enough. And so what the change is, like, because that has been the change of station, right? And so you can act on that. Sure. We had a larger sample, and this may be smaller, right? And so that would be smaller. This is further away. Right. And so you're exactly right. So I never go. I feel like I like the data convince. Yes. Greater than. That's yes. Okay. To get that problem.
Yeah.
And then on people,
Yeah.
it says like.
Yeah. No, point zero.
It's meters and it says. Here.
Yeah, right.
And it says 6%.
No, variables are the questions.
Those who took. Right.
So. I just get number of students.
Didn't.
Yes.
I. Zero 7 4.
Yeah, so we thought, you know, keep 4 decimal places for that.
Oh.
Only because it helps on the round offs. I keep it a little bit more.
So when I'm subtracting from here, I keep that 4.
Yep.
Am I subtracting?
Yep, you're exactly right. And so that, if you got something weird, it may just be ordered on questions. So subtract in the numerator, is what that is, and then do your division. And that'll stay on the thing. But recognizing that you're like, ah, that feels wrong, is a good sign that probably it was ordered on questions. Uh-huh. So that thing does. There you go.
What else?
Yeah, go ahead. And then that is your observation. So now things are scaled.
So where does the 60 come in?
Well, you really used it here. That makes sense.
Okay,
So
yeah.
it's just scaling it to a proportion instead of it being a count.
Oh,
That's what
okay.
happened.
Okay, thank you.
Yes.
And it's
It uses the soccer questions that are in part of it, which that's all. Yes. How do you know? Okay. Yeah. No, it's 6%. Make that a decimal. We've got 6%. Correct. And so then now you're okay. Yeah,
but then she told me that you were over here. So I made that.
Right, you're gonna have
I subtracted the discrepancy from 0.06. And I divided it by 4.
Number 4 was just like the.
I did get that answer at first. Wait, did you do all?
Get that, it's like weird.
Oh, that's
Yeah, and then number 5 is. Like figure out the problem.
And then I is so value for like this,
Yeah.
right? So yeah, you are right. You need to do like a C score.
Distribution, which is very, like, mine is the mean, which is like, that is divided by the standard deviation, which I used from that. So, yeah, and then I'm trying to see if you I got it.
I did, that's the answer I got when I did it all.
Yeah.
There's like.
It's okay. Yeah. What she is.
Yeah. Yeah, that's what I got when I did it all together.
One
Yeah, I
of
just subtracted.
We would have to say. Yep, so that's the checks that we're going for.
So yeah, just actually do it that way. And then just way to move on comments.
I don't know, like something into. Yeah, she's keep adding more.
Yep. Yeah, okay, still having the most for.
Yeah, okay, so.
Yeah.
I just did divide by 50, so.
There you go.
Did I have more? I need a house, man, I have a good.
You're right.
She's gonna come.
I know. Skip and go on Monday, and since you know how. Okay. Since you know how to do here, when you speak. Just make sure that's the answer. So that you're really sure you're spelling. Strong. For today. But maybe on Monday. Yeah. Oh, is that, yeah.
Yes.
Uh-huh.
I'm not doing something wrong because I keep hitting. That's the answer I got, I did it all together.
Yeah, so do your subtraction of the numerator. And give an answer.
I would like just this start assignments.
Now the bottom.
Okay, so it's like you said, order.
It is. So what was happening is it was saying like 0.06 divided by that. Subtracting that from 0.06.
Okay,
And so
so I
that's
need
why
to
you're
remember
like,
that.
that makes no sense. But that moment where you go, that's really
Yeah.
good. Because it's really good to have that gut check. You're like, no, what is happening? Because that says there's some understanding that's there.
Yeah.
So it's really good.
Okay.
Sorry.
So like one. We get. Point. Okay. 9.1. You get that? Yeah. Okay, so she said that there's like meetings like centers, can you do this, and then once we get that image, that's not on this, and I'm gonna write. Yes. And then if you don't order, well, no, it's. No, 0.5. So, yeah, 0.95, and then I told her, 9.1, so they guys will get that right.
Yep, yeah.
And going.
All right, as y'all are wrapping things up, you got lots of things happening this weekend. This afternoon at 11:30, I'll be on the 4th floor down in the middle by the elevator. If you got any questions on homework or finishing this learning check, whatever that looks like. And then don't forget Sunday night, I'll probably send you an email to remind you. That I'll be in the math and stat lab if you want to drop in virtually. Okay. So yeah, 0.6 if you issue. So we can do say,
And then 6.
Yeah. So you made 60. And so then you use as that.
Well, yeah,
Like. Yeah. This was.
so.
But-
Probably, right?
Behind 0.07, it's 6. Big difference. The 0.07 is 6. It makes a lot of sense. And then that's another application, whatever it is. All right, I'll see y'all on Monday. Study this weekend. Send me questions on Teams. I'll be around.
Yeah, that's it for that. I don't have to report. It's on everything. And my ours, wherever it is, the percentage is smaller than.
60% people experience rebound.
Yep.
You're welcome.
Okay, but we.
How did we feel on that last? I think it's an email to Tara. But I think it's just because I missed the notes. So I was.
Let's try and do that fast. Not a government. And I think that helps a lot.
I have 2 exams on Monday. The rest out.
It's dark. Right.
I've never been that hard to do. This is my second time taking stats. I took stats fall semester last year and I just barely failed it. I was so mad. I just barely. Are you? Yeah. My first. Are you? How do you like it so far? It's definitely starting to get hard. So you kick it in and yeah.
Now, it's just staff have students, so they may get their questions and they're like, I'm not really sure which ones. Then they may say, she's probably done all of her audits, whoever. That was her part. So, yeah. Well, today we're open 10 to 12. So they have shorter hours on a Friday just because we don't have Friday classes. 12 to. I have class at 1.
I think I'll be.
Okay.
I think I'll be done with my second class before,
Okay.
11. I think.
Uh-huh. Let's see. Okay, so what does 68% make you think of? 99.7 would be 3.
Oh, so.
No, there we go. So we want to go 1 standard deviation from the mean. So you know your mean and you know your standard deviation. So find the 1 standard deviation below and 1 standard deviation above. That's what you're doing. Mhm.
Alright.
So sort of like how we drew that one, right? And we added, you would also do the subtraction and then report that interval.
Okay.
You're welcome.